Thanks for joining us to another webinar organized by Princeton here. And today we have Benjamin Golub with us. Hi, Ben.
Hi, great to be here.
Great, Ben. So Ben will talk about modern AI for economic research, I guess more broadly for social science research. And he will provide an overview of tools. So we're looking forward to Ben's presentation. We decided to split this webinar into 3 standalone videos. This video is about prompting LLMs. What are the best practices and best heuristics, how to best prompt LLMs to get the outcome you want for your economic research. There's of course another video which then tells you how to best use Cursor, where you can embed and orchestrate many parallel prompts in the Cursor environment. And the final video is about refine.ink, the tool Ben provides to the profession where you can generate referee reports to your academic paper. It identifies errors in proofs, including the appendix, errors in the empirical strategy, shows you where there's a lack of clarity in the paper, and some inconsistencies. Let's start with, in this video, about the prompting of LLMs. Ben, the floor is yours. We're looking forward to your explanations. Thanks again for doing it.
Thank you so much, Markus, for organizing, for having me here, for running Markus Academy. I'm really excited, and one of the most exciting things to me actually over the last few months has been seeing a lot of the people that I admire and respect most in the profession get really excited about AI. So Mark, I love the overview you just gave. It's very sort of open-minded and forward-looking. I've chatted a lot to a longtime mentor of mine, Drew Fudenberg, about it, and it's just been amazing to see Drew, for example, being really into knowing about what's coming and how it can be used in theory. So I think that there's sometimes outsiders, running. So I'm here in my capacity as an economic theorist and as a co-founder of an AI startup. And in the latter capacity, I sometimes hear the stereotype that academics are conservative or they're not into the latest tools, but I really feel like the profession is super excited and hungry. So my talk today is going to be from my perspective as a researcher, how I've used AI to improve the process of research for myself and my students, and then how that led me to starting this AI startup, which is about doing one thing that I think the current tools don't do, the other tools don't do perfectly. My co-founder Jan and I decided to start up something where we would make our own, and I'll talk about that in the end. A surprisingly common experience for people who try to work with models in connection with math is the model says something really stupid, and because math is so objective, it's like if a student said something completely wrong or stupid, it would be important that they understand why what they said was so wrong in context. But that turns out to be exactly the wrong thing for LLMs, because wrong information in the chat poisons the context and causes the model in a way to try to reconcile it with everything that comes afterward. Okay, so a mental model that I have is that an LLM is a superpowered but limited assistant. So it has incredible intuition from knowing basically the entire internet. It can do algebra and numeric, and they have perfected tool use for doing numerical calculations. So a heuristic that's for me pretty accurate now is if you know how to use these models well, any math problem that could reasonably be asked on an exam at Caltech where I went to college could now be is solvable basically by LLMs with very few and interesting exceptions. So that's an incredible power. And the other thing is, talking to my friends who are professional software engineers, certainly the latest Claude model produces code for a well-defined coding task. That is, but like for if the code would be, let's say, 2 to 3 pages written out the proper way, Claude will just do that for you at the level of a good, junior professional. So that's shocking. And so what are the limitations? Why is it a limited assistant? So one fundamental issue is that, the model doesn't understand you or your project or the often implicit norms that govern how you're writing. Like, for example, proofs of the same proposition in, I work in networks, so sometimes I read papers in a combinatorics journal and sometimes I read papers in the AR, and the rules for how explicit and how detailed you should be and what you should, what an intuition means are extremely different, and there's just no way for the model to know that intuitively. They now do use your chat history to learn something about you, but partly because it just takes information that it doesn't have, and partly because it's not very intuitive, it doesn't have great taste. You end up with internally correct but inappropriate responses, and so that's what you have to manage, these limitations of lacking context and lacking sort of critical taste-based judgment. There are more limitations. Something that the AI companies are constantly fighting to do better on is that the models have tunnel vision and they focus on executing the immediate instruction, but often that leads to bad results more broadly. So you say, I really want this code to compile, and it will really try hard to do that, but often by disabling a key, commenting out some key code that was important for the security of your website, or that was important for checking, doing a dummy check that your standard errors were computed correctly, it might just find that too difficult to do, and so it'll say, okay, placeholder code here. That's an example of tunnel vision where it gives you what you think you want, it reward hacks, but you end up with a product that's worse.
That's the laziness of the models.
Exactly. It sort of optimally achieves the goal. So, and related, there's this bullet and the one after. A mathematician whose AI commentary I really enjoy, Dan Litt, says that the models seem to have, if you think about their revealed preference right now, and this is the next bullet, they seem to prefer truth to a lie, to saying, I don't know. And so, and that's something that, again, OpenAI, for example, Adam Kalai there is trying very hard to make the models better on. But basically, giving a conclusive sounding response that addresses the question, finds all the integers such that whatever, that's something it really wants to do. And if it has to take a shortcut or do some wishful thinking to do it, it will do it in preference to saying, I don't know. And so understanding that aspect of it is very important. Robert raises a point in the chat which I think is important. He asks, what about the potential synergies between seemingly unrelated conceptual modeling approaches? Because, yeah, it's a very natural, the way I interpret that question is, if you think of these models, they have an immense amount of data about, let's say, biology and game theory. And it seems reasonable that a human being who learned everything about biology and everything about game theory would find some new connections. But basically no striking long distance conceptual connection has been made with the help of LLMs, which suggests that in a way all of this post-training has made them narrow, and so I expect that to change, but with research on how to leverage its sort of global genius. But it is, I think, thinking about those facts, like that it's never made long-range conceptual connections, helps us understand how it behaves for the purpose of being an assistant.
But are you saying LLMs do not make a connection across fields, or they do make?
They do not, in the sense there hasn't been a discovery certainly where an LLM pointed out something, it's pointed out that the proof of something exists, but only when, I guess what I'm saying, kind of an unexpected analogy, for example, is I think the consensus among AI researchers is that there are way fewer of those than we would naively expect from the amount of information in the model.
Because we had a webinar with Sanjeev Arora, a computer scientist, and at Princeton they have this metacognition, where LLMs actually figure out new concepts or new patterns which nobody ever discovered. And the example is that, let's suppose the concept of a metaphor doesn't exist. And the computer or the LLMs could actually identify the concept of metaphor, develop this new concept. And that's why I thought it might also be possible to draw connections between biology and networks in economics, let's say.
Yeah, I think so. My take on that is that it's a research. I think researchers who work with LLMs, obviously at a much more super expert level than we do, and can modify them at under the hood, can get those kinds of things to happen. But chatbots,
I see.
The tunnel vision phenomenon is very pronounced with the consumer chatbots. That's maybe a way of saying it.
And this don't wanting to say, I don't know, like not being like Socrates, that's baked in. It comes naturally out of the LLMs, or is because some in OpenAI decided, oh, we always want to pretend we know?
I think that's a great question. My understanding of the science on this is that the scoring rule used in post-training makes a big difference. This is basically Adam Kalai's research, that there's not a reward for, I don't know, guessing is the rational strategy to improve the score, and so that's why it behaves that way.
Okay.
So let's go forward. We're gonna so I think I'm gonna cut. I want to show you guys some amazing tools with cursors. So we're gonna skip some material in the middle here, but I do think that a very important meta principle. So there's this mental model of what it is, a brilliant but weirdly limited and tunnel vision assistant. And one funny thing is that people who are used to managing junior employees often find LLMs kind of familiar, that you have to give it it doesn't know much that it needs to be helpful, but it's very eager to take in information that you give it. And so you have to provide that direction. And people have been talking about this in the chat, decompose complex tasks, ask it to explain things back to you, to put more information in context that's compatible with how you see things, how you want things. And then, think of processes of iteration, but again, processes, iterate in ways that are smart. For example, avoiding poisoned context, so getting rid of bad information. And being a good micromanager, and I'll give you an example of a good prompt, and then we'll see many more examples. So sort of usual prompting tricks. Basically, I think the prompting wisdom is about knowing how to actually efficiently micromanage this employee. And by giving it really good guidance, you can help it produce stuff more like the high quality stuff in the training data rather than the low quality stuff. I want to contrast a bad and a good prompt. So here's a problem that I had. I wrote a proof in a network theory paper, and I realized I had not handled corner solutions. I assumed everything was interior. So if you just give the poor prompt, you give the proposition statement, maybe with a little, a bit about the model, the essential notation and the proposition statement, and you say, handle the corner solutions. You're going to get an output, but it will often be quite random. It might be an undergraduate teaching note on this. It will probably introduce different notation that you didn't mean. A good prompt for this type of task has the sort of some key moving parts. So I often write explicitly your goal, so we know what success means. It's to make surgical changes, so not to rewrite things too much. Make surgical changes to the proof of this proposition to fully and correctly handle corner solutions. And then you would paste the full proposition statement. It's helpful in this case to give more context. So as long as my current proof doesn't have wrong statements, I'm fine giving it. And even the referee comment that prompted this conversation is valuable context. And then I'll often give notes that shape exactly how I want it to behave. So these are like the house rules for this task. Write concisely, closely following the style and notation of the existing proof. Do not rewrite things from scratch. Often it'll have a tendency to be verbose and write these flowery explanations. If you don't want that, you can tell it in advance not to do that, rather than seeing it happen and then reacting by saying, no, 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 you should have written that shorter, So this is like some of the moving parts. I'll introduce a few more of prompts that tend to deliver good results.
And you think that's the same whether you use ChatGPT, Claude, or Gemini?
Yes, I think for this stuff, yeah, the models are incredibly convergent in terms of what works for them. So these are 4 pieces of advice in Paul Goldsmith-Pinkham's blog post, which I fully agree with, and so role playing, which was not in the prompt that you just saw, but you can enrich the prompt. If you say your role, you can tell it who it is. So I often say when I'm trying to get it to write a hard probability proof, I'll say you're a senior probabilist who's expert in these types of methods. And then I'll say write for Econometrica. And that puts it in a frame of mind where like we're being serious, we're trying to do stuff correctly. Even though the model has chain of thought naturally, you can prompt it extra to say, let's make a step-by-step plan of what parts of the proof currently are incomplete. Let's figure out what needs to be added to make them rigorous. Let's add that surgically, and then let's review what happened and make sure it was correct. And current models are good at actually, if you tell them the step-by-step, they'll go and carry it out step-by-step. People have different preferences, whether they prefer to be there for every step and have it stop and deliver the intermediate results, or whether you give it the whole thing and go have a cup of coffee and come back and see what happened. And we've already seen this, but don't argue, okay? Now, one thing that comes up when you work this way is this is not all going to fit in one chat, especially if you're doing a few of these tasks. So often what starts to happen is, you want to do this problem by problem, but you have many problems. And so when you're using a chatbot in your web browser, you're going to want to enact this multiple times in parallel or in sequence. And it feels like organizing a little bureaucracy of these LLMs doing these tasks with these good prompting practices. And of course, you want to keep context across different interactions. And so then you get into the business of writing handoff reports. As we discussed previously with context, you don't want to overload the chat with everything that's been happening in this project. So you're starting new chats for focused tasks. And something that many of you I'm sure have come up with is, after you've made some progress on a task, sometimes it's all in the file if it's a paper, but often there will be notes on a proof strategy which is not yet fully complete, but you want to compact away a lot of tangential material. And so it's very natural to ask the AI to help you in your management job and say, let's write a handoff report to the next assistant so that we can hand off this job and start with the new part of the task. So you can have an LLM generate a handoff report, and it's actually really good. You can say you're writing a report to a junior colleague who is going to take over the task from you, summarize all the essential information needed to continue with this task. And so and here's the key point. When we come to this point in the story, it becomes pretty, I bet you're feeling that this is an awkward thing to be managing with cut and paste in your browser. Like, this is not how you want to be working.
Yes, of course, another video which then tells you how to best use Cursor, where you can embed and orchestrate many parallel prompts in the Cursor environment. And the final video is about refine.ink, the tool Ben provides to the profession, where you can generate referee reports to your academic paper.